Welcome to the Rim Break Rodeo. We hope this video helps.
You start by confirming prerequisites: JDK installed, Java home set, and a simple Java class ready. First, pick which generator you will inspect: Java. Util. Random versus secure random, because their internal state differs. Then compile a tiny program that produces several outputs from the same instance so you can observe behavior. Once done, log the outputs and timestamps to a file for reproducibility. Make sure to use fixed input patterns rather than random external noise to keep deducing the seed feasible. Now you collect consecutive outputs and analyze how the generator transforms state. For Java, util. Random treat it as a linear congruential generator. Outputs are top bits of the 48-bit state, so you apply modular inverse and bit shifts to reconstruct the prior state. For secure random, identify the algorithm provider. Often it is non-trivial and may require native entropy, so it may be infeasible. Once you compute candidate states, verify by seeding a local random instance and comparing forward outputs to your captured sequence. Finish by converting the reconstructed internal state back to the original seed format Java expects and reseed a random to confirm exact reproduction of outputs. If the sequence fails to match, expand your dataset with more consecutive outputs, check for off-by-one shifts in bit extraction, and ensure you accounted for Java's seed scrambling policy. One key troubleshooting tip: if runs are concurrent or use secure random from the OS, results may be non-deterministic. Switch to single-threaded tests and Java. Util. Random for reliable.
Thanks for watching. Consider subscribing if we helped you.